Let's take a very simple look at math. Now, math, in my opinion, is something that is made a lot harder than it actually should be, especially since most of us went through primary school, middle school, and high school kind of learning how to loathe math. It's almost kind of like it's a national sport. No one likes math classes, and if you don't have to take a math class, somehow we find a way out of it because math is not important, it's not easy to learn, and it's something we're not going to use. Now, for the rest of this video, I'm going to try to dispel a lot of that and try to get you over your fear of math and kind of go over like how simple it actually is at its lowest common denominator, pardon the pun. Now, math is all around us. I truly believe that we're mathematical creatures. Before we invented astronomy, before we invented calculus, before we invented the batting average, before we've invented statistics or any sort of advanced math, such as maybe trigonometry or differential equations, we were kind of wired to kind of do math anyway. I truly believe that when we were, in the early stages of our being as human beings, we were constantly doing math. We were always looking to see like how far it would to hunt for food. We were always thinking about how many days do we have until it gets cold again, or how much do I have to eat to sustain life between me and my family and the people around me. So at the very beginning of humankind, we were kind of wired to do math. Math is part of us. It's not something that I think that we learn. It's something that I think has evolved with us. And even though nowadays when we think of math, we think about high school algebra or college calculus or differential equations or anything like that, I really believe that we're kind of wired to look at math in a more simple point of view. So let me explain. Now, if you're shopping at a store, there are things that you're going to be doing mathematically in your head. You're going to think about, number one, how long does it take to get to the store? Number two, you might think about how long will it take for me to actually do the shopping? You might think about how many of a certain item do I need? Do I need 8 shirts and 3 pairs of pants, or 2 pairs of pants, a pair of shoes, or what have you? And you're also thinking about maybe how much you have to spend and if the things that you're going to be buying you have enough money for. So right off the bat, just for something as simple as going to the store and going grocery shopping or going clothes shopping, your mind is already mathematically going through all of that. So I truly believe that if you just take those simple instinctual inner steps of the way that our brain processes math, you are capable of doing the most advanced math known to mankind, or even invent your own math. It sounds hard to believe, but I really believe that's true, that if you can do things such as addition, subtraction, multiplication, and division, those are the 4 basic arithmetic constructs that math is based off of. If you could do those 4 things, there's really no limit on what you can do in all of the most advanced math. The problem is we've been kind of programmed maybe, or even observed or experienced, that math can be hard, and perhaps we have felt defeated at math. And if you're like me, I don't like to do anything I'm not good at. So if you're not good at math, you tend not to want to do it at all. So let me explain to you the very, very, very basics of math and mathematical systems. Now, all of math, everything is based on quantities. Now, a quantity is something that can be observed, I call it in natural life. Like, for example, if you go to the grocery store, you can say, if you go to the produce aisle, there are, for example, 100 tomatoes, 50 oranges, 3 peppers, and 75 onions, or what have you. Now, every time that you look and you count something in your head, that's called an observation. So we are saying that you are observing a quantity. You're observing the number of apples, the number of pears, the number of whatever in the produce aisle or whatever you'd go shopping for. Now, from that quantity, what you can do is you instinctually you go through your head and you could do things with quantities. You can add them together. You can subtract them for each other. For example, if your significant other said, I want you to get 5 oranges and 5 pears, or 20 oranges and 20 pears, you can add those quantities and then you could get the result of those quantities. In this case, like 20. Or you could actually subtract them. Like, for example, if I went to buy 10 apples and I had to give 10 apples away, I would have 5 left. Or multiplication. If I went to the store and bought 5 apples over a week, and if the week has 7 days in it, I would have 35 apples. Now, that sounds simple and very, very, very basic, and you might be rolling your eyes, but if you can do those things, you could do some complex math. Just by that statement, for example, if I went to the store every day for 1 week and bought 10 apples, at the end of the week I would have 70. In your mind, you've already done a couple of things. Number one is you've observed a measurement, right? You've measured a week, right? A week being 7 days, and you also had an observation of how many pieces of produce that you bought, and then what you did is you took that and you multiplied it by the days, and you got what we call, a product. So anyway, you can take very basic mathematical constructs and do more and more and more complex things with them. So as I was mentioning just previously, when we have what's called an observation are things that we observe in I say natural life. You can point to it and you can refer to it. And all those numbers are not surprisingly all positive numbers. Like, for example, if we went to the store and I asked you, I want you to count all of the bananas in the store, you would be able to do that. You would be able to take my task and come up with an observation. You would say that I have observed that there are, let's say, 750 bananas in the store. Or I could say things like, tell me how many minutes does it take you to walk from the front of the store to the back of the store? And I know that would be subjective, but that's something that you can measure and you can observe. You can say that, for example, it takes me 3 minutes and 25 seconds to walk from the front of the store to the back of the store. So really the foundations of math are really about observations and measurements. So you can observe things and you can measure them. Now, as I mentioned before, I'm trying to break this down into such small, easy bits that I want it to even sound silly. And that's kind of the point. So a lot of you are listening to this saying this sounds like it's really kind of meant for preschoolers. And maybe it is. But what I'm trying to explain to you, though, is these are the seeds that you already have in your mind. And if you can do these things, you could do the most advanced particle physics or astrophysics or any sort of math known. You could do things such as mass dilation, time dilation. You could do advanced statistics such as, applying laws of large numbers and things of that nature. So when you actually take the small parts of your mathematical brain, you're doing more and more complex things. And that's all math is. All math is taking things you already know and building one step above it. And that's why I always say, especially for people doing math or young adults, or I have experience with maybe teenagers and above doing math, is always start with the basics and work up. I usually get a student or someone here and there say, oh yeah, well, you know what, I've already had high school algebra, I don't need to take that again. I haven't had it in 5 years, I don't need to take it again. I'm going to go right into college calculus. And I would say things like, don't shortchange yourself. Don't think because you need a refresher on something that somehow that makes you not as smart or not as good if you already know that. Because just like anything else, to warm your mind up for math is very similar to how an athlete warms up when, he or she does an Olympic event. If you watch the Olympics and you watch, the gymnastics team, the male or female gymnastics team, right before they go out and they do their Olympic caliber performance, they're stretching. And they're just kind of just like slowly going through the motions on things and kind of going through mentally and physically what they need to do. If you look at a musician, a brilliant classical musician, they're doing the same thing. Before they actually go for their performance, they're practicing a scale, they're practicing a bow hold or something simple, to kind of get them in the swing of doing things. So math is like that too. So, just like in my example with the Olympic athlete and the musician, no one looks at these folks when they're warming up and say, "Oh my gosh, look how easy this is." Why in the world are they doing something demeaning to them? But for some reason, we do that with math. We're like, wait a second, well, I don't need to do arithmetic or general math or algebra, but I always say quite the contrary, you do. Because before you could do more advanced things, you need to be able to master the simple things. And that's a very simple concept, but everyone seems to forget that because we all think that we should rush and we should do things. And my point is always that if you rush through the things that you should know, you're actually taking longer to do the more complex things. So think about that as you're going through math. Now let's talk about mathematical quantities in a little bit more detail. So I was mentioning previously that math is really about observations and measurement. Now, when we do that, we can break that down and give it a term. So think about that. If you're going grocery shopping and you need to buy 25 things, and let's just make this up. You need to buy, 2 crates of eggs. You need to buy 3 cans of corn. You need to buy a roll of paper towels, and you need to buy 2 canisters of coffee. What you can do is basically just as I mentioned, is those are observations. You can observe that. You could say, these are my observations of what I need to buy. You can also put some sort of measurement on that. Like, for example, how long did it take me to drive to the store? Or how long did it take me to shop? When we do these things, when we take our observations and our measurements, what we're doing is we're using something called, this is important, descriptive math or descriptive statistics or description. I call it descriptive or description or descriptive math. Descriptive math is things that you observe. What we can do is we can take from our descriptive math is we can model it, and that's called putting a descriptive model together. Now, like for example, if I'm driving to the store and I measure that over a period of a year, and it's 365 days that I drive to the store, and every day I measure how long it takes me, and it could be 20 minutes and 18 seconds, and day 2, 18 minutes and 10 seconds, and so on and so forth until I get to 365. So at the end of a year, I would have described 350 trips, how long it took me to get to the store. And from there, I can use descriptive statistics to actually put together a mathematical model, right? I could look at that and I could get a mean time, I could get a mode, I could get a median. I could do some moderately complex statistics, such as from those observations, I could get a variance, I could get a standard deviation, and from there I could do things such as do some more modeling and look at confidence and things of that nature. That's all good and fine. Now, after we have descriptive math, we have what's called predictive math. Predictive, like predicting the future. And quote Einstein would say that the future is just a past event that doesn't happen yet. Now, pause that and think about that like for the next 10 years. Seriously, the future is just a past event that hasn't happened yet. That's actually math, where Einstein is really saying that you can model the future based on past results. So I could take my descriptive model, in this case for how long it took to go to the store, And I could actually, from there, put a predictive model. I could say if I know the past, what I can do is I could use prediction or predictive modeling to predict the future. So math is really broken down into description and prediction, depending if you're observing and measuring things that have happened, as opposed to prediction, where we're actually taking our descriptions and taking our descriptive model and making predictions from them. So basically, if you could do the most simple things in math, such as measure things and addition, subtraction, multiplication, and division, you could do more advanced things, such as put together predictive and descriptive models. Thank you for listening. I bid you all a very well rest of the day. Thank you.